So we're given this problem, and the first thing we have to do is figure out what information do we have for the solution and for the cell. So we have cell in the solution, what pertains to the cell, what pertains to solution. So I created this table. The stuff in black is what we're given, the black ink. So we have temperature for both because the cell is in the solution. So even though we're given the temperature for the solution, we know that the temperature of the cell would be the same. So I put those on both sides. I have the psi p for the cell, which is 3 bars. I have the molar concentration of sucrose in the solution, but I don't know what it is in the cell. And that's what they want to know. So that's the big question. What is the molar concentration? But I have it for the solution, so it's 0.4 molar. I don't know what the solute potential is, the psi s, for either one. And I don't know what the water potential is for either one. So I'm going to begin with the one that I have the most information for. So I have the temperature and I have the molarity for the solution. So I'll begin with that and I'll use the equation ICRT. So my ionization potential is 1. My concentration is given right there, it's 0.4. R is a constant, and T is simply 23 plus 273 to make it into Kelvin. So I put that all in, I come up with negative 9.7 bars. So now I have my solute potential for the solution, which is negative 9.7 bars. Okay, second thing I need to do, I need to figure out what is my water potential inside and outside the cell? Well, the question says they're at equilibrium, which means that my water potential is the same. Okay, so third thing then is I need to figure out what is my water potential for the solution, and I already know it's going to be the same as for the cell. So my water potential for the solution is the same as my solute potential. Why? Because my pressure is 0. So if I put a 0 in my equation, which is water potential is solute potential plus pressure potential, this is the 0, which tells me that psi equals psi s. So now I have my solute potential for both, for my solution, and that's the same as for my cell because they're in equilibrium. So now step 4, what can I do next? So I look at the whole thing and I figure out, now that I have this, I can figure out my solute potential. So my solute potential is not going to be 9.7 or negative 9.7 because I have a pressure. So all I have to do is take my equation, psi equals psi s plus psi p, flip it around, put psi s on one side, so psi s equals psi p minus water potential. So I plug in the numbers I have 3 bars, minus, so minus negative 9.7, which gives me negative 12.7 bars. But we're not done yet. So our last step, now we have everything but our concentration for the sugar solution in the cell. But now I can go back to Ys equals ICRT. So I know that my water potential is now given right here at 12.7. I have 1 for my ionization constant. I have the R for my pressure constant. I have my temperature. So I have all this. I'm missing C. So I multiply these two. That's negative 24.3. I divide my negative 12.7 by negative 24.3. I end up with 4.5. And then that's the answer they were looking for. So first thing, create the table. Put in what you're given. See what you can figure out that can feed into the other side. What can I figure out on the solution side to feed into the cell side? And then use these equations to come up with your answer. And that's it.
That's it.
So, thank you.